on this computer.
Huh?
It's Monday, January 9th, and we are in math. Today in math, we are going to do lesson 7.04 and then do a Dreambox lesson. I'm going to make breakout rooms for kids who have already done the 7.04 lesson and quiz. I have a couple kids, not so many, but I have a couple kids who've already done that. So create. And so if you have already done it, raise your hand right now if you've already done the lesson and the quiz. Okay, so it's just Kainoa. Kainoa and Christian. Christian, you've done it?
Yes, I did it.
And you had to score like 15 or more on the quiz. If you got less than 15.
I got 20 out of 20.
That's awesome. Okay, so you may go to your breakout room and work on Dreambox if you've done that. And Liam, you've also done that? Yeah? Okay.
Yes.
Everybody else stay with me and let's take a look at that lesson. So here we go. I'm going to share my screen and we're going to go to our home. Oh, lovely. And go to math. And remember that in this unit, you really need to stay up with the math because it's coming fast and furious with a lesson like every day. So today's 7.04. If you haven't finished 703, 702, 701, you need to get on that. Okay, it says 704, due today, January 9th, practical and fractional. Here we go. Paxton wants to paint something more abstract this time. Pablo is asking Paxton to subtract fractions, so he knows how much space to leave for other colors. Let's learn more about how to subtract fractions. And honestly, if you understand how to add fractions with equivalent denominators, with like denominators, then you're going to be able to subtract fractions with unlike denominators by creating equivalent fractions. So that's just what we're doing, is the same thing you did with addition, but with subtraction. So in other words, if I said to you, how many pieces of cake do I get? And there were two of us there, then you would say, well, you each get a half a piece of cake. But then two more people came and they said, well, what is 1/2 minus 1/4? Because I want 1/4 of the cake. Well, I can't take a half of a cake and just take away 1/4 from it. I'd have to cut it first, wouldn't I? I mean, I could stick my hand in it, I guess, but it would be a mess. So that's what you're doing when you're creating a like fraction. You're saying, well, I'm not going to call it 1/2. I'm going to change it into fourths. So I'm going to make an equivalent fraction. So if I'm going to subtract 1/4 from 1/2, I'm going to have to cut that cake in half and call it 2/4. 2/4 minus 1/2. And I know that I know how to do that because when I change my number in a fraction, I either use multiplication or division. If I use multiplication and times 2 by 2 on the bottom, I've got to do the same on the top. So here we are with the lesson. We know how to add fractions. Now we can learn how to subtract. Let's test what you already know about equivalent fractions by trying your hand at these questions. 3/4 minus 3/8. Should I change my eighths into fourths or my fourths into eighths? What do you think?
Fourths into 8.
Because you could change your eighths into fourths if you could split the top number in half, but you can't. So if I'm going to double the bottom of this number, what's the top going to be? 3/4 changes into how many eighths? Say it out loud, somebody. I can't see the chat right now. You might be typing it. Nope, nobody did it yet. So guys, if I have to times my 4 by 2 to make it 8, I've got to times my 3 by 2, and it becomes 6/8 minus 3/8 equals 3/8, right? Boom. Submit. Outstanding work. Okay, next. Again, 7/10 minus 2/5. This time, I think I'm going to change my fifths into tenths. So I'm going to double the bottom. I'm going to double the top. What does the 2 become when I double it? Hold up the fingers.
4.
You're right. 7 minus 4 is 3, and the bottom is tenths. 3/10. There it is. Okay. You've done marvelous work. Let me show you the next one. on my whiteboard. Oh, you can't see my whiteboard right now. Okay, 7/8 minus 3/16. What am I going to change here? What am I going to change in my denominators? I'm going to have to make my eighths into
16.
Yep. So what do I have to do to times 8 by to make it 16?
2.
2. So what do I times the 7 by?
You times the 7.
2. So if I times the bottom by 2, I have to times the top by 2. So it becomes 14/16. I double the top, double the bottom, right? 14 minus 3 leaves 11. Kainoa, what's your question?
I finished,
Okay, do another one.
but I'm done.
Do another one. All right, Pablo wants to explain subtracting fractions to Paxton. This will help him find the difference between the supplies he's used and the supplies he has left. Subtracting fractions with unlike denominators is like adding fractions with unlike denominators. You can't do it. You can't sit there and say, well, 5 minus 3 is 2, so this comes out 1/2 or something. That would be crazy. We know that 1/3 of a cake and 1/5 of a cake are different. So this time I can't just double it, can I? So how can I find a number that both 3 and 5 will go into? One way is I can times 3 times 5 and I get 15. So I know that 3 goes into 15 because I just times it by 5. And I know that 5 goes into 15. So let's see if that's what they do. First, multiply the first fraction by 1 whole with a denominator that's equal to the blah, blah, blah. That is very confusing. In other words, multiply the denominators and get 15. Now ask yourself, what did I have to times 3 by to get to 15? Well, I had to go 3 times 5. So I'm going to have to go 1 times 5. And this number, 1/3, becomes 5/15. Now I'm going to have to change the other number, the 1/5, into 15ths, right? So step 2, 1/5, I have to times 5 by 3 to get 15. So that's 15 on the bottom. So I need to times my 1 by 3 because I always have to do the same to the bottom and the top. So now it's 3/15. And now I can subtract them. 5/15 minus 3/15 leaves 2/15. Okay. We now know how to subtract fractions with unlike denominators. We must make sure that both fractions have the same denominator, common denominators, by making equivalent fractions. Let's follow along with an example to learn more. So in this case, is there anything you can times 3 by to get to 16? What do you think? Anybody? Are you guys listening?
Yep.
Okay. Well, 4 goes into 16, but 3 times 4 equals 12. And 3 times 5 is 15. And 3 times 6 is 18. So 3 doesn't go into 16. So I'm going to have to find a number that both 16 and 3 will go into. Now, if I times 3 times 16, that's 3 times 10, which is 30, plus 3 times 6, which is 18. 30 plus 18 equals 48, right? So 3 times 16. I can always times my denominators and get a number. So in this case, if I times 3 times 16 on the bottom, I got to do it on the top and turn it into 33/48, which is a really weird fraction, but it works. Now I got to do it to the other number. So being careful that this time the 16 or the thirds, I had to times 16. 2 times 16 is 32. 3 times 16 is 48. Now I have both numbers at 48ths, which is a weird thing. 33 minus 32, it leaves 1/48. So that was kind of a hard one. But what they're trying to get you to understand is that you can always multiply the denominators to come up with something. So in this case, 4 doesn't go into 15 easily. But if you double 15 to 30, does 4 go into that? Nope. So they're suggesting you just times 4 times 15. So step 1, 4 times 15 is 60 down here on the denominator. Now I had to go 4 times 15, so I got to go 3 times 15, and that's 45. Step 2, I take my 15. Now I'm not timesing it by 15, I'm timesing it by 4. So I got to do the 9 times 4 and I come out 36/60ths. And finally, step 3, I do the problem. I want you to use paper and pencil as you're working these. Try your new skills on this printable, it says, but I believe that the final thing is going to be a quiz, not this. But let's do the first one, 3/5 minus 3/8. Grab a piece of paper and I'm going to change to a whiteboard and we're going to work this one together and then I'll leave you guys on your own to work on the quiz. So let me open that up and let's type the numbers in there. If I can get them in there, text. Whoa, where'd it go? Is it giving me a text box? No, how come? Oh, there it goes. Okay. Let's make it 36. Okay. So we've got 3/5 minus 3/8 equals. Okay. So in this case, we have to ask ourselves, what number do 5 and 8 have in common? Well, 5 times 8 equals, anybody tell me? What is 5 times 8? 5, 10, 15, 20, 25, 30, 35, 40, right? 40 equals 40. Ignore the little periods that are getting in there. Those happen on the site for some reason whenever I end a sentence. 5 times 8 is 40. So our bottom number is going to be 40. So here's the thing. I need to change 3/5 into 40ths. So I'm going to times it by 8/8 because that's the denominator on the other number. 3 times 8 is 24. 5 times 8 is 40ths, right? 24 40ths. Now I have to figure out what 3/8 is in 40ths. So if I times the first number times the second number's denominator, then I have to times the second number times the first number's denominator. So that has a 5th underneath it. Oops, let's expand that so it'll fit. Come here, you. Oh, I hate it when these things do this. Come on, expand. There we go. Equals. So here I got to go the top numbers. 3 times 5 is 15. And the bottom numbers, let's just forward it. The bottom's number, 5 times 8, we already know is 40. Now I've got my two numbers. All I have to do now is I have to subtract them. So 24 40ths minus 15 40ths equals, well, I subtract the top numbers, 24 minus 15. Let's see, that's 5, 6, 7, 8, 9 40ths. Okay. If you think that you understand how to do this, let me see, let me close the whiteboard. Then you may head to a breakout room. I think you've all got breakout rooms set up, and you can work on quiz 7.04. If you do not understand it, stay with me now, and I will go through another one with you, okay? So you're going to do lesson 7.04, then quiz 7.04, then make sure you've finished all the others, 7.01, 7.02, 7.03, and then do a dream box, okay? I'm gonna stay in the main room. If you have questions, you can come to me. If you finish, come in and chat. Nora, question?
I'm
Oh, sorry, you guys